NASA's ingenious fix, reviving JunoCam's Jupiter images. Imagine a camera, millions of miles from home, facing a critical challenge that could spell its doom. This isn't just any camera, it's JunoCam, a vital instrument aboard NASA's Juno spacecraft, orbiting the gas giant Jupiter. Designed to capture breathtaking views of the planet's storms and moons, JunoCam was never intended to last long, just 8 orbits around Jupiter. Yet, remarkably, it survived for 46 orbits before succumbing to the harsh radiation environment. But here's where it gets controversial. During orbit 47, JunoCam began to show signs of radiation damage. The voltage regulator, a crucial component, seemed to have failed, threatening to blind one of Juno's few windows into the Jovian system. With no way to physically replace the faulty part from Earth, NASA's Jet Propulsion Lab had to think creatively. Instead of giving up, the team opted for a daring solution. They heated the camera. Annealing, a process used to reduce microscopic defects by heating and cooling materials, was their chosen method. Using JunoCam's onboard heater, engineers raised the temperature to 77 degrees Fahrenheit. Miraculously, the camera regained functionality and produced clear images for a short period. However, the reprieve was temporary. By orbit 55, the images became corrupted again. And this is the part most people miss. As a close encounter with Jupiter's volcanic moon Io loomed on the horizon, the team faced a critical decision. They chose to take another risk, this time pushing the heater to its maximum capacity. For days, there were no signs of improvement. Just before the December 2023 flyby, however, the images suddenly came back into sharp focus. JunoCam captured stunning details of Io's North Polar region, including sulfur dioxide frosted mountain blocks and newly formed volcanic flows that had never been documented before. Without that last-minute fix, this opportunity would have been lost. This second annealing attempt not only salvaged the Io flyby, but also opened up new possibilities for spacecraft maintenance. The technique has since been applied to other Juno instruments, though NASA hasn't disclosed all the results. What we do know is that this experience is reshaping how future missions approach resilience. We're learning how to build spacecraft that can withstand radiation, said Juno's principal investigator, Scott Bolton. This knowledge will be invaluable for everything from Earth orbiters to defense satellites and deep space probes. JunoCam has endured 74 orbits so far, but as the mission delves deeper into Jupiter's radiation belts, image quality is once again deteriorating. Whether another repair is feasible or worthwhile remains uncertain. For now, NASA's innovative remote repair trick has extended the life of the camera, provided valuable data, and offered a rare glimpse into one of the solar system's most extreme environments. NASA saves JunoCam 370 million miles away, the ingenious repair technique. Imagine being 370 million miles away from Earth, near the massive planet Jupiter, and facing a sudden crisis with a camera that is crucial to your mission. This is exactly what NASA encountered with its Juno spacecraft's JunoCam, and the story of how they remotely revived this vital instrument offers fascinating insights, not only into space tech, but also into overcoming the harshest radiation environments. But here's where it gets controversial. Could this approach reinvent how we design and maintain spacecraft, or is it just a clever workaround with limited future use? In December 2023, NASA's team operating the Juno spacecraft, which orbits Jupiter, pulled off an extraordinary feat by repairing JunoCam, the spacecraft's color camera, from hundreds of millions of miles away. This camera, essential for capturing vivid images of Jupiter and its moons, was starting to fail under intense radiation exposure. The details of this daring rescue were revealed during a technical session at the Institute of Electrical and Electronics Engineers' Nuclear and Space Radiation Effects Conference held in Nashville on July 16, 2025. JunoCam is designed to capture visible light images in full color and is mounted outside a protective titanium vault that shields the camera's sensitive electronics. This location is a double-edged sword. While the vault protects most electronics on Juno, the camera itself is exposed to extreme radiation environments. Jupiter has the most intense planetary radiation belts in our solar system, making JunoCam's position particularly vulnerable to damage. Initially, mission planners believed that JunoCam would function for at least the first 8 orbits around Jupiter, but everything beyond that was uncertain. Surprisingly, the camera performed flawlessly through 34 orbits during Juno's prime mission phase, delivering spectacular images that significantly contributed to our understanding of Jupiter. However, by the time Juno made its 47th orbit, the first signs of radiation-induced damage appeared. By orbit 56, nearly all photos were corrupted, rendering the camera nearly useless. The team struggled with diagnosing the problem from a spacecraft so far away, over 370 million miles. Although radiation was the suspected culprit, they zeroed in on a failing voltage regulator within JunoCam's power supply system. With limited fixes available, the team turned to an unconventional and experimental technique known as annealing. Although typically used in materials science and electronics, annealing involves heating a material and then gradually cooling it to repair microscopic defects. JunoCam's imaging engineer, Jacob Schaffner from Malin Space Science Systems in San Diego, the company that designed and manages JunoCam, explained, annealing can sometimes change the physical properties of materials like silicon at the tiny scale, but our hope it would fix this planetary camera was uncertain. The team commanded JunoCam's single heater to raise its temperature to 77 degrees Fahrenheit, notably warmer than its usual operating temperature. Everyone waited anxiously. Remarkably, immediately after this heating cycle, JunoCam began producing clear, high-quality images again for several orbits. However, as Juno ventured deeper into Jupiter's radiation belts, degradation resumed. By the 55th orbit, the photos deteriorated again, filled with noise and streaks that no amount of processing could fully correct. Facing a looming close flyby of Io, Jupiter's volcanically active moon, the team resorted to a bold last-ditch effort. Extreme annealing by cranking the heater up to maximum power. Initial progress was slow, and the first week showed minimal improvement. Then, just days before Juno's closest approach, only 930 miles above Io's surface on December 30th, 2023, the images dramatically improved. This success allowed the team to capture breathtaking images of Io's northern polar region, revealing sulfur dioxide frost-covered mountain blocks and previously unknown volcanoes with vast lava flows. As of now, Juno has completed 74 orbits around Jupiter. Unfortunately, the image quality began to decline once again during the 74th orbit, reminding the team of the ongoing battle with radiation damage. What makes this episode truly interesting is how the techniques developed for JunoCam are now being adapted for other instruments and engineering systems on the spacecraft. These experiences shed light on how to build and maintain spacecraft that can survive and even thrive despite hazardous space environments. Scott Bolton, Juno's principal investigator at the Southwest Research Institute in San Antonio, highlighted the broader implications. Juno is not just exploring Jupiter. It's teaching us how to make electronic systems more robust against radiation. These lessons are hugely valuable for future satellites orbiting Earth and beyond. Juno's mission management and development have involved a wide network of organizations. NASA's Jet Propulsion Laboratory, JPL, in Pasadena, California, leads project management and operations. The Southwest Research Institute handles mission science. Lockheed Martin Space built the spacecraft, and international partners, like the Italian Space Agency, contributed instruments such as the Jovian infrared auroral mapper. Could this radiation annealing technique revolutionize long-duration missions to hazardous environments, or is it merely a stopgap with limited lifespan? As spacecraft venture to ever more extreme locations, should NASA and the broader community invest more in such repair methods, or focus instead on designing fully radiation-hardened hardware? What do you think? Can we count on these kinds of fixes to keep future missions alive, or is this just a happy accident? For more fascinating insights and updates about Juno's journey, visit https://www.nasa.gov/Juno. NASA's Radiation Rescue. How JunoCam defied Jupiter's hell to capture Io's volcanoes. Imagine this. A daring last-minute maneuver saves a crucial camera from the relentless radiation of Jupiter. NASA's Juno spacecraft, launched in 2011 to unravel the mysteries of Jupiter's origin and evolution, faces the solar system's most intense radiation fields. In December 2023, JunoCam, the spacecraft's color, visible light camera, started showing signs of radiation damage, prompting the mission team on Earth to devise a remote fix to capture the Jovian moon, Io. The solution? A seemingly straightforward process: heating the instrument and then gradually cooling it down. Like the classic turn it off and on again trick. This method not only saved the day, but also offered valuable insights into spacecraft radiation tolerance for scientists beyond the Juno team, as detailed in a recent Jet Propulsion Laboratory statement. Initially, scientists believed JunoCam, with its optical unit exposed outside a protective radiation vault, could withstand radiation for the first 8 orbits around Jupiter. Surprisingly, it wasn't until the 47th orbit that radiation damage became evident. The team discovered that the voltage regulator, essential for JunoCam's power supply, had been compromised by radiation. With limited options from millions of miles away, they turned to a less conventional technique called annealing. This involves heating a material to reduce defects and then slowly cooling it. We were aware that annealing could microscopically alter materials like silicon, but we weren't sure if it would fix the damage, said Jacob Schaffner, a JunoCam imaging engineer from Malin Space Science Systems. We instructed JunoCam's heater to raise the temperature to 77 degrees Fahrenheit, 25 degrees Celsius, much higher than usual, and waited anxiously for the outcome. Their strategy initially succeeded, allowing JunoCam to capture clear images for several orbits. However, as Juno continued to plunge into Jupiter's radiation fields, the damage resurfaced. By orbit 55, our images were riddled with streaks and noise. Michael Ravine, JunoCam instrument lead from Malin Space Science Systems, explained. We tried various image processing techniques, but nothing worked. With Io's close encounter approaching, it was a Hail Mary moment. Our last resort was to max out JunoCam's heater and hope extreme annealing would save us. Initially, the extreme annealing seemed ineffective. But as Io drew nearer, and with just days left, the images dramatically improved. On December 30th, 2023, JunoCam captured stunning, detailed photographs of Io's North Polar region, revealing previously unseen volcanoes. This achievement was presented at the Institute of Electrical and Electronics Engineers Nuclear and